So we just finished building this beautiful little robot right here. This is our very first project. It's called a TurboPi. It's made by HiWonder. It is an AI vision robot car. So we're going to be able to program this with Linux and ROS and Ubuntu and all that stuff. It's running a Raspberry Pi. But first, let me show you how we assembled this robot.
Welcome back to DreamCloud and Millennial Robotics. Today we have a special video for you. We're going to be building our first robot. This is called a TurboPi and it's made by a company called HiWonder. Now, this robot runs on a Raspberry Pi computer, which means it's going to allow us to run Linux, specifically Ubuntu 22.04, which is commonly used in open source robotics projects. That's the same version of Linux that we have running on our lab computer. So essentially, what this is going to allow us to do is code or program our robot in the lab and then transfer that file right onto the Raspberry Pi. So the kit is going to allow us to build a robot from scratch without having to physically produce our own parts. So we can just focus on the software side of things for now using this kit of parts. This is going to also allow you to get into robotics easily by purchasing one of these kits. I believe this was around $200 for the standard Raspberry Pi 4B computer. All right, so we're just gonna slide this off. All right, so opening the box, it looks like we have this little introduction sheet that just explains to us what we got, all the physical components. You can see listed here. On the inside, little explanation diagram. Comes with a nice little screwdriver. This is our motor controller, and this is going to allow the Raspberry Pi to create instructions that this can execute in electrical impulses. So let's just put this aside for now. Inside we also have these little balls. I believe we're going to be able to use object detection with these. So we'll set these aside for now. Comes with a little USB power cord. This looks like it's the servo motors. So we've got two servo motors. I believe this is for the camera movement. Just put those over there. This is part of the frame. This looks like it's an upper portion of the frame. Here we have another cable. This looks like it's going to go right into hopefully the motor controller and possibly connect that to the Raspberry Pi. We also have a nice little screw kit. This is a bunch of different size screws that we're going to be using on here. And now this is the frame. So this is the back portion, or this is the elevated portion that you can see right here. So we'll set that aside. We also have this. Looks like this is a nice battery pack. So we'll have to include that. Here is our Raspberry Pi Model 4B. This is our computer right here. So this is all of the components that are commonly, used on a motherboard, all on a small platform. And this computer actually runs Linux right on it. It's going to run Ubuntu 22.04. It allows us to actually create actions and movements for our robot. So this just looks like it might be a battery charger. We'll have to use that in the future. Here's some nice cables. That looks like that might be connecting all the motors together. Here we have a couple of small components, so make sure you don't lose these parts. That looks like a little heat sink. I believe that's going to sit on top of our CPU on the Raspberry Pi. Here are the sonar. I believe these are sonar vision type of sensors. So instead of it using LiDAR, it uses that. We also have this. This is going to be our line follower. So this is going to be able to scan if we put some tape down on the ground. So we can do some projects with that. I don't know what this is. This looks like it might be our camera. So this is the little camera. It's on a little motherboard. It's going to be able to allow us to see in the future. We're going to be hooking it up to this. So the tele operation for this project is going to be handled by this Samsung tablet and this kind of gaming controller that's used on tablets. Here's a couple of the motors that are going to go on the wheels. We have 4 of these motors in total. And what that's going to allow these wheels to be able to do is move omnidirectionally. So these are the wheels that you see that can move forward and back, but they can also move side to side. So these are going to be good for autonomous robots that can move around in tight spaces. I would like the robots that we build to be omnidirectional wheels. And so we're going to figure out if that works. If there's a better system, we'll use it. Sometimes 2 wheels that drive and steer is the answer. We also have these large batteries. So batteries included, and we have the charger and the battery pack. And then we've got these are going to be like mounting pillars almost between each structural component. And then here is the frame. So this is essentially what everything sits on. This is the platform. This is the kind of thing that we're going to 3D print. So in summary, we are going to print better versions of this that we can mount all of our robotic hardware on. So this is really not much included as a body. And as you'll see, this robot is very exposed. It's really easy to work on. It's like a little fun car. But in the future, we want all of our components to be inside of a container. So that's what we're going to be building in the future, is something to kind of cover and wrap all of our hardware components inside. So that is it for the box. So now that we have all of our components out of the box, I'm just going to lay them out across the table so we can get to them. Our batteries, and the battery pack, our motors. So this little segment right here is going to be everything we need to mount the camera to the front. So this little box will actually mount on the frame like this, and then using a couple different segments here, we're going to be able to mount the camera on top of here. This is our little motor controller, and this is going to hook right on to the Raspberry Pi. So this is the camera that's going to mount to this unit, and this is the sonar that's going to mount to this unit. These servos are going to allow the camera to move this direction and this direction. So I guess we have 2 degrees of freedom with these servo motors. They also come with these little arms, which we're going to have to connect. The line follower, and this is basically a bunch of sensors that can detect different colors on the surface on the ground. So we'll keep that over here. Finally, we have the Raspberry Pi. This is our little Raspberry Pi computer, and this basically runs ROS and sends any of the signals that we are going to program into the robot, onto the computer. It's going to send it over to this motor controller so that it can actually send electrical signals to the motors, which will involve sending signals to the servo motors that can control the camera, and the regular motors which control the movement of the wheels. We could also add a claw later. We could expand this, but essentially what you have is 2 components that work together. One of them is the brain. It's doing all the thinking. It's a computer. It runs Linux and Ubuntu and the robot operating system and all your Python code. That's where all this lives. Then we take all of those commands and this is where AI can be integrated. And then we send all of those signals over to the motor controller, where this just sends a signal to either turn this way or turn that way. So all of the comprehension, all of the high-level math that's going on is happening here, and then this is just a low-level instruction set going straight to the motors. So now everything is laid out and we just have to put it all together. Well, the first thing we have to do is actually scan this QR code right here. And this takes us to a PDF file, which is our instruction set. So everything is actually here. It's a Google Drive that they share with us publicly. So this is gonna have all of our instructions, so we can take this one step at a time and just install it. So make sure that you scan this if you have this kit. So the first thing we're gonna do is put the sonar sensors in the case. It looks like our plug right here in the back is going to be on the top, which is where these little tabs are. So we're going to put it in just like that, and then we're going to find the bolts that hold it together. It looks like we're going to be using this screw. It's really, really small. It's really, really tiny, and the instructions say it's a self-tapping screw, which means it has a pointy front that you can screw in directly to the back side, and that's exactly how that works. You're gonna hit the corners first. You just wanna get things snug, and you don't wanna over tighten, because it's just you're drilling straight into a circuit board. If you get it snug, it's gonna be good enough. Just to recap, we have this on the top. We also have the plug on the top. And that was because we needed to be able to get those pins that come through the front. I'm not sure what those pins are used for, but they're gonna be used for something. So this sits inside of this box. So the second thing we have to do, mount this faceplate inside of the box. And then we're gonna put a servo motor here, our first servo motor. To connect these two, we're gonna actually use these black screws. So the screws go in through the top, and they actually thread right into the other component. So this piece is threaded. The screws just go right through here, and I'm just gonna make that nice and snug. And that's our little robot face. Cute, right? We're gonna get our first servo motor and install that inside here. And the first thing we're gonna do is pull this off. So you've got your control wire, which is gonna be sending a signal to the control board to tell it where it is. And then the other two are just power and ground. So that's why this is a triple cord setup, and this is a common coloring. So you know what cord does what, but you just have to plug all three in. Like the servo motor goes forward towards the eyes. So that's the only thing you have to worry about here, is just making sure that that motor is on this side right there. And then we're gonna use our little screws. Now we have the whole head complete, and then the camera is gonna sit on top of here. So it almost has two faces. So it's gonna have these little eyeballs that are gonna see using sound, and then it's gonna have a camera on top that can see obviously using vision, and that's our little head. So these bolts connect here, and then these bolts connected on top, and we're done. So before you actually screw this part down onto the base, we need to make sure that we wire it, meaning this sensor needs to have a cable that sends information back to our Raspberry Pi. So just line these up and plug them in. Once that's all plugged in, then you can fix that onto the body. And then we just need to find the 4 holes that these go into. We're gonna check to see which bolts work with these little columns. The first 2 go in these holes all the way in the back. Hold the bolt there with your finger and then thread that on. Like the forward bolt just behind this little slit. So that's the bolt for this guy. Get those tight by hand, and then that's done. Now we've got this base here, and we've got our little robot head complete. So I actually took the plastic off of these motors because I feel like this is gonna melt if it gets too hot. And these parts of the robot are actually gonna heat up as we're sending electricity to the motors. So the next thing we have to do is mount all 4 motors inside of our frame. To do that, we're gonna use 8 of these long screws and 8 of the corresponding nuts. The motors go inside just like this. This part sticks through here. The holes to mount it line up, and the motor faces this direction. So it can really only go in here one way, and then we can just slip the bolts in just like that. We can see them on the other side. So then we're just gonna take you can get both sides pretty tight by just holding that with your finger. So just do that on all 4 motors. And number 4, so you can actually just tighten these down and hold the back of the nut with your finger, and then just make sure that all the wires are loose, they're all free, because they're gonna feed back up inside here to connect to our motor controller. So the next step is gonna be installing this line follower underneath the front of the robot car, so as it's driving along, it can see if there's some kind of a line on the ground. So basically we're gonna be using these guys that are going to allow this to float some distance from the top where we're gonna mount it. And then we're just gonna put these bolts up inside. So as you can see, the first 2 holes on the very front now give us these nice little columns that we can attach our line follower to underneath. Make sure when you're doing this that the sensors are facing up when the robot is upside down, so that when you flip it back over, they're facing down. Those thread in nicely, and now we've got a professional line follower installed underneath the chassis, so we can drive around and hopefully follow some lines. We might have to drive outside the lines too. The next step is actually going to be installing the robot head onto the chassis. For that, we're just gonna use 4 black screws. Just make sure that your cord is clear and coming out the back. So that means our head is now completely attached to the frame or the body. We've got our sonar sensors right here. We've got our servo motor ready for our camera. We've also got the line follower installed underneath, and we've got these 4 pylons ready to mount something up here. So this next step is very important because this is where we're going to be mounting our Raspberry Pi to our control board. Before we actually mount the motor controller onto the Raspberry Pi, it's going to be important that we install the heat sinks. So that is done by peeling off this little piece of tape on the bottom and just applying it to the right location. Now I've looked this up because they didn't explain this to me, but basically this chip right here needs a little heat sink right on top. Basically, that's gonna take the heat from the chip and distribute it into that little metal panel. And you have to do the same thing with this one. So this is your little mini heat sink. It's essentially doing for this little computer what that fan over the CPU is doing over there. So that's 1 and 2. And then the last one is the biggest one, and it actually goes over the CPU right there. So that's all 3 heat sinks installed. One for the CPU, the other 2. So now that the heat sinks are installed, we can put our motor controller on top. Just make sure to line up the pins on this side and the port on this side. That fits together nicely. So the first thing we have to do to get these to mount together, so we're not just relying on the pins and the port, is we need to attach these 2 things. So these are little plastic parts that are gonna go underneath the Raspberry Pi, and then this is gonna go between the Raspberry Pi and the control board, almost like a little mini column. So all you need to do is hold this here and stick this in so it threads right in to the base, just like that. So this has the threads on it, and then this is just a little spacer. And then we're just going to take a regular screw, and that's going to bolt right into the top of that. So that's what we're looking for right there. That type of connection. Bolt, spacer. This is like a spacer too, but it's got a bolt on the other side. So they're both bolting in to this piece. So just repeat that on every corner. I got them with another piece of equipment for the lab. And it works quite well. So these parts are a little trickier, obviously, but I have this little tongs that allowed me to position them in there. So what you need is on the bottom here, you've got these 4 mounting, they're kind of like little nuts right now because you can throw a bolt inside here, and that's probably what we're going to do in the next step. But for this step, all you need to make sure you get right is that you have the bolts coming in here, we've got the spacer in the middle, and then you've got these kind of extended bolts that have threads inside, and we're going to mount that onto the main chassis. We're also going to need to plug in a cable to our line follower in the bottom. I'm also going to load this little memory card into the Raspberry Pi now. So it just fits in on the bottom of the motherboard. Then we're going to plug in the sensor cables, which are these 4-pin cables, to the sensor ports on the motor controller. The diagram says that this one goes for the ultrasonic sensor, and then the middle one is for our line follower. We're going to mount the Raspberry Pi onto the frame from underneath using these simple screws. Oh, now we have the motor controller here. We've got the Raspberry Pi. We've got 2 motor cables coming up that we're going to plug into our motor controller. We've got 2 motor cables coming on this side, and then down on this side we have our line follower. Important to have all the cables along the sides because we're going to put the battery pack right in the middle. So for the battery pack, we're just going to use 4 screws. They're really flat. They're just going through a really thin piece of plastic here. So just tighten down those screws, and then this is really tight, just to show you. So now we've got a battery pack right here, but it's also just missing the cable for the line follower. So I feel like we could put more room in here, or just think about those things when we're building our robot. Make sure everything has enough space. This is a very, very small robot, so everything's really tight, but I don't think we need to make ours this small. Before we put the battery case back on, I'm just gonna throw the batteries that they gave us inside here. Next step is actually just putting our omnidirectional wheels on. So for that, we have this spacer and a bolt. The hexagonal end fits inside the wheel, and then we just have this little piece that looks like that. So repeat that for every wheel. So it's important to make sure that all of the grooves are facing in like that. So that's the easiest way to say it, is that all of these lines from the top need to be facing in. And as long as you have that, see how they're facing in that way, and in that way, and in that. As long as all those lines are facing in, then it's going to be able to do omnidirectional travel. So now we've got this guy on here, and you can hear the servo working underneath. So I just finished assembling this component right here, and honestly, it was really tedious just to get all of the screws in. So this seems like a starter kit, but the type of precision that I needed in here just to put these little screws on was, to be honest, a little overwhelming. So I don't know how a kid is gonna figure out. Just the bolts and the nuts on here are very complicated. So I would recommend something much simpler. I know this is probably trying to be as simple as possible, but that connection was a little bit frustrating. It's because this whole area is just designed to accept 2 standard servo motors. And so they kind of had to like custom make that to work with this. Hopefully in the future, I don't even know if we're gonna have a camera that's movable like this. I would like to have fixed cameras to all sides, just so we can see in any direction when it's traveling. So basically that's it. You've got, the first one is left and right, and then that's gonna scan. And then this one is top and bottom, so it can look down or it can look up. Most of the time it's probably gonna be looking forward. So that's basically it. And then we're gonna put this guy on the back shell, and then we're just gonna plug everything in. So let's actually plug everything in first. It looks like here on the diagram, these are for our motors, and it looks like there's our power cable. So let's plug in all of these first. Looks like it's just gonna plug into one of these USB drives. Let's pick one of the ones that is blue, which means it carries data. That's for our webcam. So our webcam is actually almost like USB plugged into the back of the Raspberry Pi. But then the motors are gonna be plugged in right here. So there's just a grid. There's just a grid of 4 plugs. The front left wheel looks like it connects here. And I'm just gonna make sure that's the front. And that is the front. Okay, so this is the front left wheel. And it's gonna connect here. And then you have this rear left wheel here. So if you think about it, this is set up just like that. So top left is front left, top right is front right, bottom right is rear right, bottom left is rear left. So this is set up like that. Basically, it's just turned to the side. And the diagram explains that perfectly, so we don't have to worry about that. And then the last thing we have to plug in are the two servo motors. And those are going to go to these pins. Those are going to attach to the pins all the way on the back here. And the first one is pan, tilt, up and down, which is this servo. And it looks like we have 3 pins. So we're just going to make sure that the yellow is going to the white pin. And we're going to use the first set. And then this is under the wheel. This is left and right. Remember this motor's inside here. And that's going to go right next to it. Right there. So we have more pins that we could use here for more servo motors. It looks like this guy can take at least 4 more servo motors. We have 2 more 4-pin bays, 3 more 4-pin bays, and then we have a couple of 3-pin bays. So no more wheels on here, but we could put other stuff on. Before we move on, let's just put our little shell on the back so it hides all of these wires. Okay, so now the robot is completely finished, and we have a camera that can tilt up and down and left and right. We've got the 4 omnidirectional wheels. So those are all of our motors. 2 servo motors for vision and 4 motors for motion. And these are locked, but they can spin. And then inside here, we have the Raspberry Pi. So that's all of our ports. We can plug anything we need to in there. Right now, this guy, what we have plugged in goes all the way up here to the camera. So just think about this as a neat little webcam that's right on here that's plugged into a computer. So this is basically just a computer on wheels. And I think that's how we're going to start needing to think about all these systems, is they're just computers that move. I mean, that's kind of what robots are. So this is our first robot. So now that we actually have our physical robot built, we're going to need to do some work in ROS and Linux to get this Raspberry Pi ready to receive our instruction set.